So in this video, we are going to discuss how we are going to represent the electronic configuration using the Aufbau principle. So first of all, we know that the first shell has only S subshell and it has only one orbital which contains two electrons, and second shell would be having S and P or subshells, which is having S is having one orbital, P is having three orbitals. And the number of electrons, second shell would have 8 electrons, and the third shell is SPD subshells, which is having 1, 3 and 5 orbitals, having total 18 electrons. Then we have fourth shell, which is having SPDF subshell and is having 1, 3, 5 and 7 orbitals, having total 32 electrons. Now moving to Aufbau principle, which states that this is 1s, then we have 2s, 2p, then we have 3s, 3p and 3d, then we have 4s, 4p, 4d and 4f. And how electrons are going to fill in it? Let's see. So first electrons are going to fill in 1s orbital, then it is going to move towards 2s orbital, then 2p, then 3s, then 3p, and after filling 3p it is going to fill 4s, then it is going to towards 3d, and then it will move towards 4p. So this will be the order. I can write it like 1, 2, 3, 4, 5, 6, 7, 8, and then we have this one 9. So if we want to represent the electronic configuration of fluorine, how we are going to do that? Fluorine is having 9 electrons, and first the electrons are going to fill in 1s orbital, which can hold maximum 1s subshell. S is subshell, it can hold maximum 2 electrons because it has only one orbital. Then we have 2s, which is again going to hold maximum 2 electrons, and then we have 2p, which can hold maximum, like how many electrons are remaining? We have 5 electrons, so it is going to have 5 electrons. So now in order to represent them in terms of their you can say noble gas electronic configuration, how we can do that? So you need to see that helium is basically present at the end of you know, like period 1. So helium has 2 electrons, and these 2 electrons are present here, 1 is 2. So in order to represent the noble gas electronic configuration, we are going to write this part as helium, and the remaining part would be written as the same, 2s, 2p5. Now we can write the electronic configuration for, let's say, magnesium. And how we are going to do that? Magnesium is 12 electrons. Electrons are 12 here. First it is going to be 1s. 1s can hold maximum 2 electrons. 2s can hold maximum 2 electrons. 2p can hold maximum 6 electrons. Total number of electrons become 2 plus 2 4, 4 plus 6 10. Then we have after 2p you can see we have 3s. So let's write 3s, which is going to be 2 there. Okay, and now if we want to represent the orbital diagram for them, let's see what is going to be the orbital diagram and how we are going to represent them. So let's see about orbital diagram. So first of all, Orbital diagram are a visual representation of electronic configuration. So they are going to be the visual representation of electronic configuration. And what happens in them, there are certain rules to write it, that we are going to use boxes to represent, which are going to use to represent the orbitals. And then the important thing that we are going to discuss here, that arrows are used to represent electrons. We are going to use arrows to represent the spin of electron. Represent the spin of electron. And each orbital, this is, we need to remember that each orbital can hold maximum of 2 electrons. So each orbital can hold maximum 2 electrons. And how we are going to represent, like for example, if we want to represent fluorine, okay, so fluorine is F9, its electronic configuration is 1s2, 2s2, then we have 2p5. And how we are going to show its orbital, this is orbital, one electron is in this way, and the other electron we are going to show the opposite arrow, which shows that it is going to have the opposite spin. For 2s2, in the same way we are going to do like this, it is in this way, and this arrows would go downwards. For 2p5, we are going to see that for 2p5 is basically having 3 orbitals, which is 2px, 2py, and 2pz. And it is going to have, first, how it is going to fill, this is very important. First in this way, second orbital, third orbital, because it is 2p5. Now we are going to start from the first one, in this way and in this way. So this is the way to represent them. Like for example, we want to represent nitrogen N7, which is going to be 1s2, 2s2, and 2p3. Okay, so this orbital would be having 2 arrows with opposite direction, this orbital 2 arrows in the opposite direction, and for 2p3 it is going to have 3 arrows, and 3 arrows will be in the same direction. Okay, because first we need to fill each of the orbital. Okay, and if it would be 2p4, then the arrow might come at this place. In our course, we also need to memorize the shapes of orbital. Shapes of orbital. So we are having basically 2 shapes which we need to memorize. The first is for s orbital, and the other is going to be for p orbital. So s orbital is going to have the spherical shape. Its shape is going to be like this. It is like a spherical shape. And for p orbital, we are going to have dumbbell shape. And dumbbell shape could be in this way. We know p orbital are going to be px, and for py, we can do it in even in this manner, and for pz we can do it like we can arrange it in this way. Like this is arranged, as you know, it's arranged in on y-axis, so we can name it as py orbital. This will be named as px orbital, and this one is going to be in on the z-axis, so we can say it is going to be pz orbital.